So the topic we are going to cover today is probably one of the hottest of the week, so Symfony, in its second version. For those who have already heard about that, Dries talked about this topic at last DrupalCon. So before we start, allow me to introduce myself for a second. My name is Claudio. I've got 6 years of experience in PHP development, split among satellite telecommunications, online web radios, and PHP consulting. Besides that, I do also founded, and I'm also a board member of the Italian Drupal Association. But I think that's enough about me, so let's start and let's get on topic. So the first question we'd like to answer is clearly what's Symfony2? We have many answers to that. So the first one is that it's a reusable set of components based on PHP 5.3. And they have been designed to be, to solve a common problem that was present in PHP world, which is the not invented here syndrome. They strive, the Fabien Potencier, which is the father of the framework, strived to create something that was not like all the other frameworks or products in the PHP world, basically vertical solution. But it wanted to make possible to, get these components and having them reusable in any situation without depending on each other. Other than that, Symfony is also a full-stack web framework, which is built on top of those components, and which is probably the most known asset. But Drupal 8 is not going to use that part of the framework. It's just picking a few of the most important components. So besides being a set of reusable components, the focus have been also put into re-architecting it in order to be more centered about HTTP, the HTTP specification, so that even though we can consider it being a sort of MVC framework, the main focus has been on the request and response interaction that most of the application actually deal with. So other than that, it has been developed to be a promoter of best practices that we are going to see in a moment, and also a big user of the already available standards in and practices and good habits in terms of class design and coding. Last but not least, it's also a community. I've been they are already producing a lot of very impressive libraries and tools. I've seen also some guys on the IRC Drupal channel that were like really surprised by how awesome they are. But before starting analyzing the practices that lays at the foundation of Symfony, I'd like to take a look at some of the bad habits that are still affecting some of the software we're producing. I use a mnemonic acronym to describe that, and here we can see that we have some practices that describes what makes code less reusable and harder to be maintained. First of all, a pattern. Actually, it was used to be quite a used pattern, in many frameworks, but lately it's been a bit deprecated since it does introduce too many limitations to the code, such as, I mean, it's basically a glorified global variable, which with all the bad things that come with it, since I mean, it makes testing harder, and it does basically hard code dependencies in our code. So it's basically a limit. It does have too many limitations and doesn't provide many good things. So let's see what a singleton is. Basically, is a class that restricts the instantiation of an object to a single, the instantiation of a class to a single object by having a private constructor and the public getInstance method that controls the acting as a gate for the class we wanted to use. So databases, connections are a good example of how this pattern has been used, but also configurations and stuff like that. We should try to avoid it. Tight coupling is another very bad habit that will affect the code, the classes, since it hard codes, for instance, two classes, a classes into another, and thus making them harder to test, reuse, and modify. This is an example of what I was trying to explain. So in the first, can you read it? Yeah. For the first example, the house class, you can see it's directly instantiating door and window objects, which means that we cannot actually change them anymore. So once we use that class, there's just no way we can get another door or window. And that might be quite a pain in the neck. So if you think if your house is actually a third-party library, if it was designed like the first example, you wouldn't be able to replace anything of that implementation just because everything was hard-coded. A possible solution to that is the second part of the slide, where you can see that the door and the window are actually passed to the constructor. And moreover, they are no longer concrete implementations, concrete classes, but just interfaces. This has two bigger benefits. The first one is that we can actually now change the implementation at our will. And the second one is that we are not relying on an actual implementation, but just to an interface or an abstract class, which defines a higher level contract. So we are more free to, switch them at our will. The third point is untestability, in that the more our code is complex and tightly coupled, or our classes are trying to do too many things, the less we are likely to test them, because they become too complex to be tested. We cannot do that in isolation, and since we can agree we're all lazy, if testing is hard, we tend to skip it. Clearly, the more the code is complex, the harder it is to change it, and whenever we have to do that, it's harder to tell if something is broken if we don't have tests to ensure that the code is behaving properly. Another bad habit is premature optimizations. Basically, this happens when probably we are trying to write too smart code, or we are trying to focus too much on performances where actually we don't have performances problems. These affect developers quite much, I think. Performances are not always a problem, and even when they are, it's really hard that the problem happens into our code. I mean, bottlenecks are mostly in the database. I mean, not always, but likely it's there. And by the way, there are better ways to optimize performances rather than write, clever for loops or stuff like that. So just try to keep the code simple and optimize later if it becomes a problem. Naming things, you might came across this quote from Phil Cartman. So there are two hard things in computer science: cache invalidation, naming things, and off-by-one errors. I believe that naming things, other than a fundamental part of the work, and it's a good exercise to for validating what we're doing. Because if we struggle to name our classes or our functions or whatever, it means that there might be something wrong in what we're doing. By the way, remember to try to communicate what you're doing as much as you can in your classes and methods, and not to use shortcuts that don't describe the things you're doing to anyone else but you. Last but not least, duplication. There's not much to say about this. The more we duplicate code, the harder it will become to maintain it, and it becomes also much more expensive by the time. And so try to avoid it. It's not always simple. I mean, it's not always, we cannot always do that since we are always on a hurry, but it's definitely a very bad habit, and we do all know that. So we do have some alternatives to stupid code, and some of them are part of class design principles. So basically, here are 5 of some basic design principles, but there are many others. But this one, I believe, are quite important. So let's take a look at them. So this is quite a common sense principle. I mean, it states that every class should have one and only one responsibility. It's clear that the more we localize responsibility, the more the change becomes smaller, and therefore it becomes easier to modify that specific class or interface or function. And at the same time, we do reduce the possibility that ripple effects will do weird things to code. So if we have big classes and we tend to put everything in them, every time we have to change something, there's an effective risk of breaking something we don't expect. So here's an example, pretty simple example. There is this interface which seems, I mean, it makes sense, but if we identify the responsibility, the single responsibility that a class should enclose as a reason for a change, we can scratch on the surface of that class and identifies 2 different reasons for change, and two main responsibility: the connection management and the data communication. So dial and hang up basically deal with the connection management, and data communication are dealt by send and receive methods. So it would be a good thing to split this interface into separate ones, so that we better distribute responsibility. The second principle is called the open-close principle, and states that our software entities should be open for extension and closed for modification. Basically, when we have 2 classes, a client class and a server class, it's a good thing if a client depends on the server, that that server is abstracted so that concrete implementation and behavior are not binding the client. So it basically defines a way to decouple clients and services, basically, in terms of classes, clearly not a web service, is what I'm talking about. The next principle is quite a subtle one, and states that whenever we have a class that inherits from another, the child should be, the parent should be replaceable with the child without altering the correctness of the program. So there shouldn't be any change in behavior if we just replace a parent with a child. It's something that goes a little beyond the simple syntactic relationship with the syntactic contracts that are present in our code, because it introduces some semantics. But it's easier to tell that with an example that actually violates this principle and shows why we should seriously take care of how we design, the relationships between our parent-child classes. So I think that most of you will agree that a square can be a rectangle. It's sort of a special rectangle that has some specific behaviors. And if we had to model that in a class, well, in two classes actually, it might be good to implement a rectangle class with width and height and the proper accessors and mutators methods, and then derive the square class from the rectangle. We just override the setters, so to make sure that our square will always be a square. And then we are going to use those classes to, draw something on the screen. So being a square, a rectangle, we expect our function to just require a rectangle-based class to operate. But in the case we are passing a square to the draw function, what does actually happen? That the behavior that we were expecting from a rectangle we were requiring in the signature is not actually the one that we want. This is because even though conceptually a square is a rectangle, that doesn't hold true for the respective objects. So we should actually take very good care of the behavior relationships between parents and child in order to conform to this principle, because it's not always easy to spot such problems when we analyze these classes in isolation. Probably we wouldn't spot that until a bug happened, because it's quite subtle. Interface segregation is another common sense principle that basically is trying to decrease the surface of intersection between implementations. And here we can see an example. It is better to have basically smaller interfaces rather than big ones, so that our implementation don't tend to have too many relationships between them. Last but not least, one of the most advertised, probably, principle that comes with Symfony that lays beneath the most famous service container, is the dependency inversion principle. It basically states that when we have two levels, I mean, usually we think of software, if we think of software as in a stack of layers, higher levels will tend to rely on lower ones. While this principle states that we should try to invert, to change that relationship so that the higher level entities do not depend on the lower ones, and both the lower ones and the higher ones should depend on abstraction. Yeah, for instance, that diagram will show that the component A belonging to the higher level is not actually depending on the lower level package, but on an interface that is defined at the same level of the class we're talking of, the component A in this case. This is an example of that, of the not inverted yet dependency. So where vehicle being our high level class and tire being the lower level one, we see that the vehicle is actually relying on the tire for setting up its stuff, while the tire is giving some functionalities that in this case is just setting the diameter of the tire. But if we want to invert that the dependency, we got to refactor that this way, so that the tire is defined in the higher level as a sort of a contract, in this case defined by an abstract class, so that the component, in this case the vehicle, does have at his level what he needs in order to work. While the lower level package, in this case the tire, does rely on the abstraction defined by the component A level, in this case, the higher level case, and perhaps even add some behaviors to that. So this way we are reaching a better decoupling from the two layers, and this makes software and packages way more reusable. But all these things come to reality, we can say, in Symfony, since it is, as we said, based on some of these practices. And now I would like to take a specific look of some of the components that are being introduced in the upcoming version of Drupal. Namely the class loader, the service container, the dispatcher, and the HTTP foundation and kernel. So the class loader, as the name says, is an object that deals with loading the classes that we're using in our code. It does follow a specific convention named PSR0, which has been defined by several actors, Symfony and Drupal included, but there are also many other frameworks such as Joomla or Full PHP or I don't know, whatever, that are working on these standards. So this is the very first one and deals with class loading. And we have some examples of how it does work. It's pretty simple. There are two convention defines for namespaces, classes, or for older pair namespace, well, not underscore namespace classes. So basically, if we have, for instance, Symfony /core/request, it'll be converted on the file system in the path to the project lib vendor, Symfony/core/request PHP. The class loader allows us to lazily load our dependencies. I mean, the classes we're using, thus freeing us to from managing all the required ones, and will also give us better performances because we only use the class we need only when we need them. So we will have a better memory footprint and less I/O on the file system. Now, we've seen the dependency injection, dependency inversion principle, and the service container, which is also called the dependency injection container that everybody is talking about, that has been introduced with Symfony2. Basically, this component does help us dealing with the dependencies of the application, and is just one of the possible solutions to the dependency injection, to dependency inversion, sorry. So we don't need a dependency injection container to do dependency injection, and dependency injection is just one way of respecting the dependency inversion principle. It has been chosen for Symfony to use this tool, which is pretty simple actually. But let's define what's a service first. It's nothing but a PHP object with a global task. So if we take, for instance, the singleton we've seen at the beginning, that's a good candidate for becoming a service. Or a mailer class, it's good too. But I don't know, an email message is not a good candidate for being a service. It's just a disposable object, let's say that. So a service container is just an array of services, basically, a glorified array of services. And the good thing about having this tool, which can have different implementations, but in any case, the good thing of having it is that we take away from the application the dependency management, so we can see it as a sort of external agent that orbits around our applications, and therefore free us from the dealing with how do we instantiate objects and stuff like that. And yeah, in the case of Symfony, we have a configuration. I mean, we can configure it so that it will act as we actually configure it. But there are other ways to do that. For instance, Pimple, which is another service container implemented by the Sensio Lab guys too, which is basically the company behind Symfony. Takes another approach on that. Basically, it does make service configurable by using closures instead of configuration files, which is a bit lighter. I mean, it takes quite a while to befriend the Symfony container, at least. For me, it took quite some time. Another important component that has been implemented in Symfony2 is the event dispatcher, which is just a lightweight implementation of the observer pattern. We can see a diagram of that here. Basically, it's a bit like the hook system, if you want. We have two objects, an observer and an observable, and the observable is the listener, while the observable is the one who will notify the listener that some events happened. I think all of us are used to this pattern. Think of when using JavaScript, we do something that's close to that. But let's see how it has been implemented by Symfony. It's really simple, actually. We have the dispatcher, and then a PHP callable. In this case, it's an anonymous function, but it could be even a method or anything. We do add an event to the listener called foo.bar, and we bind the function we defined earlier to that event. And then whenever the dispatcher does notify that event, the function is being called. Symfony does rely a lot on events, especially for the kernel. And I think it is also a good way to, implement, to extend objects in a much more flexible way than just inheritance. So, the HTTP Foundation is a very important part of the framework. And basically, it does define an object-oriented layer on top of the PHP available functions and global variables. And it does offer some more advanced functionalities to it. But most notably, it does make testing way easier, because otherwise there wouldn't be a way to properly unit test the code if using $request or $server. In this way, it's way easy to mock requests or response. It does play nice with the command line in case of the response, and it's pretty straightforward to use. As you can see, we can create a request object from the globals and access all kind of parameters pretty easily. And we can also forge requests at our will. So you can see an example there. We can set the URL, the method, and the parameters, and we're done. We have a request object ready for use. And the same things apply for the response. We can set the content, the status code, and the headers. Check that the response does conform to HTTP specifications, and then send it. So this is the very core of Symfony2, the HTTP kernel. It's as simple as that, but it holds a really great power, because it makes very easy to make interoperable components that are based on HTTP with this component. It just defines an handle method that basically tries to transform a request into a response. And I'd like to show you the default workflow that lies beneath the default implementation. This is it. Basically, when a request arrives, a request event is fired, and if some listener, if any, does return a response, it does just skip all the central part and fires a response object and return the request, the response. In case there is no listeners that are actually returning a response, that event will drive to the routing system that deals with matching the request with an actual controller. So for instance, the routing does catch that event and tries to resolve the proper controller, then fires an event which makes possible for other listener to do stuff on the controller that has been found. The same things apply for requests. We can intercept a request before it's being processed to add stuff or remove stuff at our will. It just takes to implement a listener for that. So it does resolve the controller. It does resolve arguments, and then when it's all set, it does call a controller, which is supposed to return a response. In the case it doesn't happen, the responsibility of returning the response is handled to the view layer. So a view event is fired, and the templating engine of choice and the view layer basically gets the stuff from the controller and tries to build a response. In which case, again, a response event is generated and the response is sent out. In case any problems will just pops up, an exception event is fired so that it's possible to catch that and generate a proper response, so for developing needs, for instance. Once the response has been sent, a terminate event is being generated so that we can still do something. We cannot modify the response anymore, but we're still able to send emails, for instance. It is also possible to generate sub-requests in Symfony. We see that in the signature of the handle function, there is a request type. That's pretty useful if we have to deal with caching, so that sub-requests can be generated with different timestamps or caching control headers, so that if we have a reverse proxy, we can properly cache all the sub-requests independently, thus increasing performances quite a lot. Symfony does provide a default reverse proxy written in PHP, but we can use Varnish as well. Clearly, the default implementation takes less effort to set up. Symfony is not enough. I called it an MVC, also an MVC framework, even if it's definitely not advertised as that. But actually, it is just a view controller framework, because it does not suggest any kind of solution for the model part. So in order to deal with that and with data persistency, there are the preferred choice is Doctrine. Symfony does not want to suggest that this is the only way to deal with persistence, but probably this is the better integrated system that is available. Besides that, there's also Drupal available, but as far as I know, this one is the most complete one at the moment. It does provide a few layers of abstraction and functionalities. So besides common, that's just a set of libraries that enhance the PHP ability for dealing with data structures. There's the database abstraction layer, which is basically a wrapper for PDO that enhances its functionality. But the most interesting parts are the object relational mapper and the object document mapper. So clearly the first one, all of them tries to convert our objects into some sort of database table or document, or depending on the database, a persistence entity, let's say. It does also offer a migration system, for updating schemas or of our databases. This is an example, a very simple example of how it works. I used MongoDB because I do personally mostly use it, and so basically we have a simple object that does not have any, I mean, in this case I did extended the persistent object, but doctrine model objects don't have any relations with any persistent layer. I mean, they're just stupid PHP objects. So, for instance, in this case, we have two properties, the ID and title, that are mapped to the database by using those comments that are called annotations, in which we instruct doctrine on how it should behave about that class. So doctrine has a document manager that is completely decoupled from these objects, and whenever we need to persist, for instance, a node, we just pass it to the document manager and tell it to persist it. So our doctrine object are able to work even without doctrine. Clearly, they won't be persisted, but there will still be perfect usable objects in any application. You see, the ID there is just instructing MongoDB to use a default ID field, while the title is just instructing Mongo to create a string field in the document. I think more or less that's it. We can have many more comments, many more annotation for instructing doctrine on how to do things. It can become quite complex at times, especially when we have complex relationships in terms of SQL data structures. But it's pretty good to when it comes to having to model the the problems we're trying to solve, since it's extremely decoupled from the persistence layer. We can also configure it by using YAML and XML, depending on our taste is. But I do personally prefer to use annotation in this case. So Twig is another part that does not belong to Symfony, that directly belongs to Symfony. It's a sort of third party, even though it's been created by the Sensilab guys too. It's the default template engine shipped with Symfony, and probably is, well, without probably, it's by far the best template engine I've ever seen. It's flexible in that it is possible to change its syntax. It's very fast because it dumps the templates into PHP objects, and moreover provides a C extension, which is completely optional, of course, that improves performances quite a lot. If anybody of you was in Copenhagen in 2009, probably will remember Rasmus saying something similar for the Drupal rendering layer. And basically this is the same things. It's just 1,000 lines of C code that replaces the default PHP implementation. It is also very simple to extend it, and has a very, very good documentation. I hope that it will make it will be adopted for Drupal 8, because at least designers and front-end developers will seriously appreciate it. Here's is a very short example of how to use Twig. I do personally love the way it handles template inheritance and embedding the templates. It's very flexible, and it's like, I don't know, I used to use the Zen framework for a while, and I really, really hated all the decorator stuff that was needed for its view layer. So this looks really like paradise to me. So we basically have 3 and 3 only tags. One is for comments, so brackets and hash. One is for blocks, which is bracket and percentage. And one is for printing stuff, which is the double bracket. It is possible to define templating functions, such the node render that we can see there. They are called macros, and they are very good for reusing some template, some presentation logic. We can define blocks in the templates that overrides the base template blocks as much as we can do with classes. So it's pretty nice. And we do have quite a lot of controlling functions, such for loops, if ands, and stuff like that. And it is also super easy to access object properties and methods, as you can see, node.title, and to apply filters to them. So, for instance, if we have a title and we want to format it in order that all the words in it are uppercases, uppercase first, we can just pipe the title filter in, and it's done. Same thing, we can format dates or implode arrays very easily, and it's pretty nice to read. So I don't personally think I will ever go back to PHP. This is just for this is the reference, so you can understand how many things are available at the moment. There's almost anything from JSON encoding to debugging to it's even the divisible by test is very nice. So there's plenty of stuff, and I do really recommend it, even if you don't plan to use Symfony. It's just great. Aesthetic is a library that deals with asset management. It's still a bit raw, but it's based around 2 main concepts: the assets and the filters, so that we are able to list assets into a collection and then apply filters on them. So, for instance, if we have less files or and we want to compile them, there are already filters available for doing that in both PHP and Node.js. Same thing, we can compress our CSS files and do a lot of stuff. Clearly, using it, it does ship with Symfony as well, with Symfony2. And has a nice integration with Twig, so it's even easier to use it when it's part of Symfony. Clearly, there are, literally thousands and thousands of packages available. There are the 2 main reference sites for that. The first one is KNP Bundles, which is directly related to Symfony. It's like the Drupal.org/project for Symfony. There are, I think, 1,200 bundles already available for doing anything from integrating Twitter Bootstrap to user authentication to just name it, and probably there is a bundle for that. And The other one is Packagist, which is a repository for Composer, which is a tool I definitely recommend you to to look at, because it will be bundled with Symfony 2.1 and basically is a sort of apt-get for PHP. It's configurable by using a JSON file, and it will deal with all the dependencies automatically, downloading them, versioning them, locking them, and will also provide auto-loading for all of the included dependencies. So just bringing, even if you have to do a command line script, just throwing Composer in, getting, just writing 3 lines of JSON, and you'll have the libraries you can find on Packagist, plus all the ones you can integrate just with 3 lines of code, and that's very, very great. I mean, I spent quite a lot of time in the past in trying to, hackle things together, and by using, the new standards that are named, so the PSR 0 standards and Composer and stuff like that, it's really a matter of minutes to start using libraries and tools, where in the past it was a pain in the neck. So Packagist is the central repository for Composer, and doesn't have anything to do with Symfony itself, but it's grown. It grew up in the same environment, let's say that. I think this is it. And thank you for attending this session. I hope I didn't, bore you too much. So if there is any question, just shout. Sorry, I didn't hear you.
Was committed to Drupal core yesterday, so it's actually now in.
Oh, cool. Any question? Yep. Plenty of that, actually. Oh, sure. So is there any book or reference I do recommend? So about the patterns and the practices, there's a book from A-Press, I believe, called PHP Object-Oriented. I'll just look for it. I mean, there is a book on PHP patterns and practices. Other than that, I can actually, I do have a list of blogs to share, but Martin Fuller is probably one of the gurus of the best practices and patterns. The Fabian Potencier blog does have some very interesting stuff, especially about the dependency injection thing and how to use the Symfony components to, for instance, build your own framework. The Symfony.com website does have a lot of documentation on each single component. So I don't hear you. Sorry.
Yeah, it's rather new, but the book introducing Symfony2 is now available as a download in PDF format.
Oh, that's cool. So there's a Symfony book. You can look at the Gang of 4 work for patterns and practices. There are other things I might share, but I have a list here. I just kept it in this presentation because I was not sure if I was going too long. So, but I have a list here. Oh, well. I think I can even find it.
Just a moment while you look for the books.
Here.
I have three important things to announce. Sorry.
Sure.
The first one is that the Wi-Fi is collapsed. So we opened another one, which is Drupal 7 Rocks. And it has the same password, Barcelona. Yeah, the next one will be Drupal 6, but I don't think we'll put rocks there. And we have 2 shifts of food. So you can choose the session you want to attend. So you can have lunch at 1 or 2. And finally, the group photo will be at 6 at the outside. Sorry.
So here's the list I was talking about. The butunclebob.com does have some interesting papers about the principle I just shown today. Clearly, they're way more elaborated. There are also some good slides on SlideShare about, Symfony2 or the specific components, mostly Doctrine, Twig. Yeah, I do also recommend there are 2 books from the Kent-Beck signature series. Even though they're not strictly related to Symfony or PHP, they are basically about test-driven development and object orientation programming. So look for Kent-Beck series. And other than that, perhaps the PHP unit websites. Anything else? There? Could you give a microphone? All right. So basically, is the question if how does these principles can apply to Drupal? So basically, Drupal 8 is going to, make use of this experience in standards, practices, and development habits and principles. So it's already there. Basically, the Drupal 8 core, basically in the Whiskey initiative, is already using these components and building the architecture upon these components and upon these principles. I think that as Drupal community, we're not used to that stuff, and so we must. I think we should spend some time, studying some of them, because just started using Symfony without knowing, the concepts that led to that, which are all been borrowed by other languages and previous experience. Most of the solid things come from the 90s or late 80s, so it's nothing new at all. It's just new to PHP. So there are a lot of things that Drupal can make use of in this case, and it's already doing it. I think I run out of time. I still have 55 seconds. 4, 3, 2. Okay, thank you.